learning from experience not to cut things too fine. It's now that I'm recording in high D, it just slurps up gigabytes. So I've been underestimating the amount of memory needed. So I'm learning. All right. So where were we? So alpha A is very small, and therefore tan of alpha A is roughly alpha A. So therefore alpha A is roughly equal to beta over alpha. That's here. Okay. So if I let's see. Now what? So I bring the alpha over this side. So I'll get alpha squared A is roughly beta. And if I multiply both sides then by A, I'll get alpha squared A squared is equal to beta A. So that's where this comes from. All right. So rewrite this just as alpha A all squared. Okay, and that's roughly equal to beta A. All right. So what? That's another result that we'll need in a moment. Okay, now, and why are we doing all this? As a reminder, we're trying to derive the energy value. We're trying to find a value for the energy, the eigenvalue, your E. So we need all these stepping stone mathematical results beforehand. All right. Now we're going to find gamma squared. Gamma. Now you've not seen this before, but except in this lecture. So gamma squared will be A squared into alpha squared plus beta squared. Right? Here it is. Here it is. Here. All right. So expand this out. So you get A squared alpha squared, A squared beta squared, minus gamma squared is naught. Right? Okay, so A squared alpha squared, just the same here. Now A beta is alpha A all squared. But this is A beta all squared. So we get A beta to the fourth, right? Here. Minus gamma squared is naught. Now, remember A alpha, or alpha A is very small. It's going to nothing. So now we're starting to pull things together, right? So alpha A is going to nothing. So the fourth power will be hugely smaller than the second power, right? So this is negligible compared to this one. So just drop it, right? Just neglect it. So so what are we left with? So now so A alpha squared is roughly equal to gamma squared. Okay, so A alpha squared is roughly equal to gamma squared. So we've got that result. Now what is A alpha squared? Now wait a minute. So now we're getting another result. A alpha squared. What's that? Well, the definition of alpha is here. Okay, so square that, you get 2me. Well, we're talking V naught. We're assuming that E is less than V naught. So we're dealing with V naught. So perhaps I should have an approximate. So A alpha squared will be 2mv v naught over h bar squared. Take the A, you've got an A here as well, so put an A here. But v naught A is delta, right? Finite value, so you get 2m delta over h bar squared. And what about beta squared? If you square beta, where's beta? Here. Okay. So square that, and you'll get 2m v minus e over h bar squared, which is here. Okay, but beta squared, where's beta? Here. beta squared. So beta is A alpha squared. Where's that come from? Yeah, so you get alpha squared A squared. And you've got a beta A, so that one of the A's cancels. So beta will just be alpha squared A. Okay?